So this is a continuation of section 2.2. And just to review what we did in the last video, the end behavior. To determine the end behavior, we need the degree, which is 5, and that's odd. And the leading coefficient is 1, which is positive. And so in the last section, we were looking at these examples. So if the degree is odd and positive, then the behavior would be like this graph. So we can say that the graph rises right and falls left. On this one here, we said we need to make sure this is multiplied out. So we get x cubed minus 3x squared. So the degree is actually 3 and the leading coefficient is 1. So that's odd and positive. So the behavior is going to be the same. And then the last one here, we have x times x is x squared plus x times x minus 3. X squared times x is x cubed minus 3x squared plus x squared minus 3x. Gather your like terms. So you can see here the degree is still 3 and leading coefficient is positive 1. So again, same behavior as this one here. What we want to look at today in this video is going to be what happens at the zeros. So notice that the graphs behave differently at each x-intercept. Sometimes the graph will cross the x-axis and sometimes it touches and turns around. So what I mean by that is if you observe this 0 here, the graph is actually crossing the x-axis. But if we look at this 0, the graph is touching the x-axis and then it turns. And so our goal is going to be to figure out when and why that happens. So example 7, evaluate the graphs below and state whether the graph crosses the x-axis or touches the x-axis and turns around. So if we observe here, my zeros are at x equals 2, x equals negative 1, and x equals 4. And notice that the graph is crossing at each of those x's. In the next picture, we have x is equal to negative 2 right here, x is equal to positive 2 right here, and then we have another x equals negative 2. And at negative 2, it touches and turns. Over here, it crosses. The last one, x equals 0, is here. X equals 2, x equals negative 2, and then we have another x equals 0. At x equals 0, it touches and turns. At the other 2 points, it crosses. So we want to know what happens with these graphs. So notice in the first graph, the zeros were only repeated one time. So in other words, there was only one of these, and one of these. And the graph crossed at each point. Over here, we had x equals 2, it repeated once, so it only crossed here. But at x equals negative 2, I have 2 that are repeated, and so it touched and then it turned. And over here, I had x equals 0, and that's where it touched and it turned. Okay, so our definition is going to be related to how many times something repeats. So let's look at the definition. A factor x minus 8 raised to the k greater than 1 yields a repeated 0. X equals a, and we say it has multiplicity k. Multiplicity just means how many times it repeats itself. When k is odd, the graph crosses the x-axis, and when k is even, the graph is going to touch and turn. Okay, and so k is just that degree of the factor. So we'll look at some examples. Okay, so it says find all real zeros of the polynomial function, determine whether the multiplicity of each zero is even or odd, and how many turning points the graph will have. Okay, so the first thing is they want us to find all the zeros. So remember that to find all the zeros, we let y equal 0. Try to factor this. Notice that they all have at least an x squared. So I'm going to factor out an x squared. So if I take factor out an x squared from the first term, I end up with x squared. Factor out an x squared from the second term, I end up with x. And then we end up with 30. Okay. So now we have x and x. So 30, I can be found by 5 times 6. I need the coefficient in front of x to be a negative. So that means 6 should be negative and 5 will be positive. So I have 0 is equal to x squared, 0 is equal to x plus 5, and 0 is equal to x minus 6. So once we have the factors, we can set them equal to 0. Remember that 0 equals to x squared is the same as 0 is equal to x, and 0 is equal to x. So we can separate it as 2, and then we can subtract 5 on both sides and add 6 on both sides. So my zeros here are these 4 zeros. Okay, so I'm going to make a little chart here, zeros, and then we're going to need to know the multiplicity. And we need to know if the multiplicity is even or odd. And then we have to decide if it touches or crosses the x-axis. Okay, so our first zeros are x equals 0 and x equals 0. Then I have x equals negative 5 and x equals 6. Okay, so the multiplicity means how many times did it repeat itself. So we ended up with 2 zeros. The multiplicity here is even. So according to the definition, when k is even, then the graph is going to touch and turn. So since the multiplicity is even, then we say that it touches and turns. And then for x equals negative 5, the multiplicity is 1 because we only have one negative 5. This multiplicity is odd. So if the multiplicity is odd, then it's going to cross. X equals 6, it only occurs one time, so we say the multiplicity is 1, which is odd, so it's also going to cross. Okay. And so basically what's going on here is, let me write it on a piece of paper, the information we have so far. If we look at the behavior, this behavior here is leading coefficient is 4 with a positive one. So that's going to be going up like this. So if I was to graph this, my zeros are at x equals 0, x equals negative 5, and x equals 6, which is right here. Okay. So we know that the graph is going to rise on both sides. Now at x equals 6, it's telling us that the graph is going to cross, so this is going to come down. And at x equals negative 5, it's going to cross. And then at x equals 0, it's going to touch and turn. So the graph might go something like this. Okay. So let's look at the actual graph so that we can see what is happening. So we have x to the 4th minus x cubed minus 30x squared And so again, you can see at 6, the graph is crossing. And at -5, the graph is crossing. At 0, the graph touches and then it turns. Okay, so that is the information that we're looking for, because at the end, we're going to be able to graph the entire graph with this information. So let's try the next one. Find first the zeros. So I let g of t equal to 0. So 0 is equal to, here we can factor out a t. So if I factor out of t to the 5th, I end up with t to the 4th minus 6t squared plus 9. Okay. We can try to factor. Since this is quadratic, a multiple of 2, I can try to factor this as t squared times t squared is t to the 4th. To get 9 would be 3 times 3, and it needs to be a negative and a negative to give me -6. So I can separate this now as 0 is equal to t, 0 is equal to t squared minus 3, and 0 is equal to t squared minus 3. So I end up with 0 is equal to t. I would add 3 on both sides, take the square root. So t is equal to plus or minus the square root of 3. And on this side, same thing. Add the 3. So t squared is equal to 3. Take the square root on both sides. So t is plus or minus square root of 3. So if we list our zeros, my degree is 5, so I should have 5 zeros. So 1 0 is at t equals 0. Then I have, for this t, I got square root of 3 and negative square root of 3. And so I'm just going to make this a positive one. Since I have a positive square root of 3 here and a positive square root of 3 here, I wrote it twice. And then I ended up with a negative square root of 3 and a negative square root of 3. So multiplicity, I'm just going to call it MULT. And then whether it's even or odd. And then if it touches or crosses. So the multiplicity of 0 is 1 because it only occurs one time. So that's odd. Since this is odd, it's going to cross. The multiplicity of square root of 3 is 2. Since I have 1, 2. The number 2 is even. So this is going to touch and turn. And for this one, it's 2 as well. So this would be even. So it's going to touch and turn. The next one, let me go ahead and rewrite it. H of x is x squared minus 2x plus 1. Find the zeros. We let h of x equal 0. We can try to factor. To get 1 is 1 times 1. And I need this to be negative. So this would be a -1. And -1 will give me -2. Set each factor equal to 0. So x is 1 and x is 1. So my zeros here are x equals 1 and x equals 1. My multiplicity is 2 since it appears twice. So that's even. So that means that it's going to touch. Okay, and then letter D. Notice these are already in factored form, so we still need to solve for the x-intercepts. So I can set each factor equal to 0. Okay. So here I end up with subtract 3 on both sides. So we end up with x equals -3. This factor can be written as 0, x minus 2, since there's two of them, x minus 2. I can set each factor equal to 0. So x is equal to 2 and x is equal to 2. A shortcut here is you can see if the exponent is a 2, then you'll have two answers. And it's going to be the opposite of what's in here. So if you see negative 2, the opposite is positive 2, because then we're going to bring it to this side. So for example, here my degree is 3, so whatever answer I have, I'm going to have 3 answers. And it's going to be the opposite of this, which is negative 1. And the reason is I can rewrite this as x plus 1, x plus 1, x plus 1. So if I set each one equal to 0, so I subtract 1, and you can see I get 3 of these. Okay. So we need to know if it touches or crosses. Since x equals negative 3 appears once, then the graph is going to cross. And the multiplicity is 1, because it only occurs one time. Here the multiplicity is 2, and so it's an even multiplicity, so it's going to touch. And here the multiplicity is 3, since it appears 3 times. And so 3 is odd, so that means that at x equals negative 1, the graph is going to cross.